Hello there, I'm Malcolm Budden.
And I'm Daren Falwell.
And I'm Piotr Jablonski.
And we are the Network Freestylers. So after a little bit of an absence, we're back in the game, as we say, with Freestyle 111, and that's actually quite crazy that we've got people. 1 + 1 + 1 is 3, and we've got 3 people. As opposed to 2, which we normally have. And the reason for that is we've got a special guest today, Piotr Jablonski. He's a friend of Daren and mine, and we'll talk a bit about what the episode's about in a second. But he's a subject matter expert in service provider, data center space, and we're delighted to have him on the Freestyle today. So
yeah, awesome. Thanks for joining us, Piotr.
So I really appreciate that. So we're going
to... Thank you for the invitation, guys. It's really a pleasure to talk with you and discuss the topic.
Excellent. And we'll put all of Piotr's details about what he's doing. He's got a few different projects on at the moment, so we'll put all his contact details and company details and all that in the show notes afterwards if you want to, LinkedIn profiles, all that kind of thing, if you want to catch up with him. So what is Freestyle 111? It's going to be about MPLS and MVPN, which stands for Multicast VPN. And this has come as a result of various different discussions that Daren and I were having initially, and that's what prompted us to... Piotr's a good friend of both of ours, and it was more of a passing conversation. You fancy coming on to speak to Daren and I about some multicast stuff over an MPLS network for a couple hours? And he said yes, and here we are. So I'll hand over to Daren in a second, and he'll give an overview as to how the session's going to roll. We've got a scenario-based session, which is pretty cool. Daren's put a lot of effort and preparation into it, and shared it with the team, so hopefully it'll go well. And yeah, it's over to you, mate. So the floor is yours.
Well, thanks again for joining us, Piotr. But yeah, no, this is it's an interesting one. It's a scenario that I kind of stumbled across. I'd say through work, but you'll kind of realise as we go through the use case, it's not really. But there's some information that I was looking for specifically about how multicast functioned across MPLS and across with a layer 3 VPN scenario. So what I've done is I've kind of created this weird use case which kind of fits the technologies I was looking to deploy. Piotr's going to hopefully shed some light on how this stuff actually functions. So, but we'll step through the use case. We'll have a look at what the topology involved is, and it's a really, simple structured topology. So just step through that, how it's physically put together, and then how it logically is. We run MPLS over it. And then we want to dig a bit deeper into how the multicast works across there, how then the customer elements and the service provider elements of the multicast interact. And we've got a couple of other little bits and pieces around the edges we want to just cover up as well, but we'll come to that. So let's hit the use case. Right, so what I've got is a scenario where we've got a network that's, in fact, I'll tell you what, let's show the topology. We'll try and step this through. Okay, so we've got a network that's, as you can see, nicely structured. We've got a bit of a core going on in the middle, which is just fast, big switches in this case, but can be routing, just in order to connect a whole load of network blocks together. We've got a data center block at the top left there. You can see we've got a WAN block, which is where all the WAN stuff will terminate for this organization, and 3 other blocks at the bottom. The organization in question is a theme park. It's a bit of a classic scenario from Cisco's examination stuff, but we'll ignore that for now. But the idea with this is that because it's structured in that way, we need to be able to lay layer 3 VPNs across the top of this network, or some segmentation across the top to separate out different tenants who sit on this environment. It's the same physical infrastructure in use for all of those tenants, but from a logical point of view, they're going to have separate networks. So while we've got all these links and these if you like, it's almost a core distribution access kind of three-tier hierarchical network going on here.
I'd just say, is this a network freestyle validated design?
Looks like a big little spice topology.
He validated. No, so yes, well, yeah. So up in the top left in the data center, of course, we've got a nice little leaf spine thing going on, but then we're lifting out of that. We've got these border, this border that routes into the wider. I don't want to say MPLS because I'm sort of jumping the gun a little bit, but yeah, there'll be MPLS is involved in all this. Okay, so that's a sort of physical topology. As you can see, you've got Fairyland, Monsterland, and Vampireland down there at the bottom in the different areas of the park. In each of those areas, we're going to need these separate tenants, and these tenants will be the concessions, the fast food companies who are based in there will need connectivity, but they won't want connectivity to the same things as perhaps the ticket offices or the digital signage that's up there, or the CCTV security or whatever. So there's where our separation is in terms of the multi-tenancy in the network. Even though it's using the same physical infrastructure, we've got separate logical networks there. Okay. We're happy so far? It's pretty straightforward, hopefully.
Yeah, where are the receivers and
okay, so we'll come to that in a second. So the next layer on top of that, I suppose, is this one, which is shows how the MPLS is providing that multi-tenancy, I suppose, and the multi-VRF stuff. So we've got a pure MPLS core. It can be BGP free because we've got root reflectors sat in the middle there. We've got each of the distribution kind of border switching in each of the blocks. We're using those as PE, so they'll sit. We'll run MPLS right up to the edge of the block, and then beyond that, it will be effectively the LAN infrastructure for each of the blocks and each of the either the different LANs in the park, or the data center infrastructure at the top left there, or the WAN block there at the top right. But the idea is that VRFs are presented at each of those points, and then we can deliver them into VLANs that then are distributed throughout those blocks. Okay, so we keep it nice and simple, nice and straightforward, and look, that's it, right? What more do we need? It's a simpler use case as you're going to see, I suppose, for MPLS. You've got some firewalling up there in the WAN block that can be used to route between the VRFs, so we can provide a secure interaction between them if they're needed. We can present different WAN provision up there for different tenants if needs be. It's a really nice, clean, structured design, right?
Yeah.
But here's the trick, right? The problem I have is that we have a couple of use cases where we need to put multicast across this, okay? And layer 3 VPN by itself isn't going to help me here, because I need, well, I'll give you the two scenarios really that I'm looking at. One is I've got digital signage, okay? Digital signage which sits in the VRS, and it displays, let's say, the queuing times for the different rides in the park. Okay, and so somehow I need to get that information out without having to have client-server interaction going on. So I want to use multicast. Okay, so I've got that capability. back in the data center, let's say a server that's basically sending out all the information that needs to appear on those signs, and all those signs should need to do is just listen out for any multicast that's coming through. But they're distributed right the way across the park in the different blocks, the other side of the MPLS network. So how do we do that? That's my first question. My second one goes a little bit further than that, but let's address the first one first, shall we? So I suppose, keeping it simple, Piotr, what's your feeling about delivering multicast across that sort of environment? How would you approach it?
Yeah, that's the interesting case. Why? Because usually we have a few sources and multiple receivers. Here we have an inverted use case where we have multiple senders and just few receivers, because we have a collectors or collection points where the signage, digital signage, or other multicast are gathered and showed. So yeah, that's the inverted situation, and we can think what is the gain based on the multicast, and it's not for sure the bandwidth, because every stream from the sensor or a sender has to be delivered, has to be transferred across the network to the receiver, to the endpoint, and that's the difference comparing to the standard situation, few to many. Other characteristic we can notice here is that we have unidirectional flows. We don't need bidirectional. Is that true? Is that true? Yeah.
Yeah. So, yeah. In this case, definitely.
Yeah. So what we can notice here is that multicast is not giving us the benefit of conserving bandwidth, because every stream has to be delivered. Okay. In this case, every stream can consume just a small amount of bandwidth, so it shouldn't be an issue. But there might be a question: what is the real gain to use multicast instead of unicast, isn't it? So
I mean, so it's a valid point. I mean, you could conceivably register these things back with a central server and just have a unicast conversation happening. But I suppose the point is, from a plug and play point of view and that sort of thing, the digital signs will come on and go off all the time, right? So
some of the time as well, that's driven by the digital signage manufacturer. They might have, in my experience, like with digital signage especially, so I've worked with digital signage in hospitals before for like patient waiting times and things like that. And it's normally a result of, so I'm coming in there as a network consultant or engineer or whatever on a project, and it's like, it's probably been procured from a different department than the network department. So it'll be like facilities management or something like that. And it might have been procured with a completely separate exercise. It's a classic of departments don't talk to the IT department, or it might be vice versa. So IT are a lot of the time are the last to know. I know that's getting a bit better these days, but I think what happens in these scenarios, so for example, this is going back 10 years ago when I first dealt with digital signage, and I was doing what I thought was like a Nexus, a 6500 to a Nexus upgrade. And this thing just got dropped in. It was like, oh, we need you also to configure multicast for IPTV and digital signage.
There you go.
And then you say, well, what is this thing? And they give you the user guide, and it would say, it would give you. So we had like 3 campuses, right? So there was 3 different hospital buildings, and they said, here's the user guide on how to implement it. It needs to support multicast. And I started reading this, and we had layer 3 routed links between the 3 buildings. But the only thing that the implementation guide for the digital signage talked about was IGMP.
IGMP, of course.
So then we started looking at Q&Q to stretch VLANs, and we were like, do you know what? I know it's scary, but it's better just to enable PIM, and you know, between the 3 locations. So that was a long-winded way of saying, you know, basically, it's not. Sometimes it's just landed on your desk, and it's like, right, you need to enable multicast, because this is how. A lot of the time it can be, this is how the engineer that's coming from the third party knows how to implement it. And it might be they click on a drop-down box, unicast or multicast, and they select multicast, and then it's the network guy's problem. That's just my experience anyway, but
that's,
it's not.
No,
it's
I think
in an
right.
optimal world. In an optimal world, it's like, well, is it unicast better versus multicast, and what are the trade-offs? But certainly in my experience anyway, it's like, deal with that.
No, I think you're absolutely spot on. You're spot on. I mean, it's that same thing we talked about it before, about design trade-offs and compromises. You know, you would love to design things the way they should be designed, but if you're doing that, you've always got to design for everything else out here and here. But often you're presented with those things, and they come into your design, and your design's only that wide, and you need to deliver this thing that services all of that other stuff. And that's what it is, you know. And in our scenario here, that's exactly what we've got. We've basically got the way that they do the digital signage is that it uses the multicast capability, because they have a server that's sat in that data center block.
So can I ask you then, Piotr? This scenario lands on your desk. How would you push back? Like just as a sidestep conversation.
I wouldn't push back actually, because multicast is giving the simplicity for the access layer. I mean, you can get any device, so you can just give this device from the factory, and without you know, any significant configuration, you can bring it to the specific area. In a unicast way, you need to configure exact IP address of a destination, and you need to provide, let's say, visibility of this IP address. What if this collection point is, for example, should be secured? Then we need to reveal the IP address of the collector, which might be, you know, in a way not secure. Of course, somehow could think, let's do network address translation, but that is not the proper solution. So without unicast and going for multicast, we avoid revealing in this multi-VRF solution, we avoid revealing destination IP address, which is good, which is, you know, providing additional level of security and simplicity especially for access layer.
Yeah, great. I think it's just keep it simple, right? And again,
yeah, keep it simple.
From that scenario where it's supported by a different bunch of people. Again, you mentioned the hospital thing there, Malcolm, and there's always that scenario, isn't there, where you avoid changing IP addressing of things when in a hospital, because it costs an absolute fortune to go and get the third party to come back in to change the IP address on all that important kit that you absolutely need up and running all the time, right? And
yeah, I mean, that's
much the same.
That's really my experience, is like things like digital signage. It's not in IPTV and things like that. There's normally a third-party vendor that come in with a cookie cutter implementation approach, and that is like, this is how we install it. So if you want to install it in the normal way that we do it for 99% or 95% of our clients, then you need to support multicast. So yeah, that's the joys.
Yeah, but what is also additional observation here is that we keep providing the solution simple using multicast, but for the end users. Because multicast in a way is, of course, a bit more complicated for the service provider itself, or for somebody who needs to provide end-to-end connectivity. Of course, we transfer this complexity to the team, but this team is, let's say, more capable and can react quicker for the configuration in the core instead of configuring and sending specific support on site to reconfigure camera or reconfigure sensors or reconfigure digital signage or any element which we have in the access. So it's better trade-off to accumulate complexity in the core in this case.
Yeah, understood. So it is about, I suppose it would be a slightly different scenario if you had an alternative provider, a service provider, providing that MPLS core in this scenario. So you have a customer organization and you have a service provider organization, and then the customer have the access at the other end. Then you've got the complexity of having to communicate that end-to-end configuration requirement through a service provider in the middle, who you then have to interact with on a more as a buffer, I suppose, between them. So you have to communicate that requirement through. That becomes more complex because obviously you've got communication to happen there. You've got to make sure that it's fully understood by the service provider, and the statement of work for them is very clean cut and well defined, right? So that's where it becomes difficult. In our scenario here, we don't have that problem because it's the same people managing and maintaining the MPLS core in the middle as it is each of the blocks for the distribution and access switching. Yes. So thankfully we don't have that problem. Yay! So now we need to consider, right? Well, how do we make this thing happen? So I'm just going to scribble a couple of things on here just to give an indication of what I'm.
So just before you do that, Darren, I just wanted to check in from a moderation perspective. So you had the 4 points on the slide. One of them was the topology. So do you want to just quickly summarise the topology then before we move on to the next part in the use case, or do you just?
Yeah, sure. Why not? And that's kind of where I was going, I suppose, with this. So again, going back to our digital signage use case, what we actually have is this. Hopefully this drawing will work. Let's see how we go. So up in the data center space over here, and it's not. There we go. And it's come up red for some reason, but that's fine. We have a VRF. And within that VRF, we have our digital signage server. Okay, and then down in Fairyland, the same VRF has our signs. Okay, and then we've got the same VRF over in Monsterland, and the same VRF in Vampireland. Okay. With a number of signs in each of those. The complication will come where we also have. Let's see if we can change my colour and see if it works. That's not working. Okay. Can you see the red is showing on there?
Yeah, that's
cool. Okay, good. I'm struggling to change my color here, but
so meantime I will ask just to double check, do we have layer 2 and layer 3 boundary on PE devices? Is that correct? Or is there layer 3 stretch, I mean layer 3 till the access in Fairyland and Monsterland?
Yeah, so that's a really good point, and one I should have added to the drawing. But basically, yeah, we've got this is all the extent of layer 3 is from here to here.
All right.
Okay. Within the user space, so the user space down here, this is all layer 2.
All right.
Over here, the data center, it's a spine leaf. So
layer 2 over layer 3.
Yeah, layer 2 over layer 3, potentially whatever it needs to be, and then over in the WAN block, it's all layer 3, just basically taking WAN connectivity and redistributing it into the network in effect. I think I've realised why it's only allowing me to draw in red, because I am red in the annotation. That's fine. This is fine. So what we've got is VRF1. Okay, VRF1.
I can throw VRF blue if you.
I think you probably do, and I think that's probably why that's got confused. But essentially, what we've got is multiple VRFs in the access layers down here. Yes, thank you. Draw those ones in blue for me. And so the blue VRFs also need to have those digital signs. So we need to do some clever stuff somewhere along the line of distributing that multicast between VRFs through the network. So that's our second stage. Our first stage is getting that continuity across the network in one VRF of multicast, and the second stage is then how we allow us to effectively route multicast between VRFs. Okay, so I think that's pretty much the summary at a high level. It's only taken us half an hour to get there, so it's all good.
That's fast for the network.
Fast for us, right? It's fast for us. So let's remove all the annotation and see where we go from there.
Brilliant.